Okay, yeah. Let's start. Yeah, today we will continue to talk about Fourier series computation. Yeah, and for today's goal, and firstly, we will try to review the definition of Fourier series representation for periodic CT signals. And then we will try to study 3 cases of typical Fourier series computation problems. Yeah, this is today's goal. And then, firstly, let's try to review like a Fourier series representation. About the Fourier series representation, we usually call it FS representation. What do you remember? Yeah. 2 different things like series, like signals synthesis and signals analysis. Yeah, for the signal, okay. Yeah, this is like what name for this one? Are you sure? Yeah, synthesis. Synthesis, which means it can be combined together like that. You can see this is sound. Yeah, this is just like a combine different access and then generate the signals. Yeah, this one for this one because we just use 2 pi over t replace the omega naught, and we call it signal synthesis. Yeah, by the FS representation. And the other one is signal analysis. Yeah, this is CT signal XT with carried property with fundamental frequency omega naught equal 2 pi over t. Yeah, this is just the condition. And this is for the signal analysis, we mainly focus on the coefficient. Am I right? Yeah, do you remember? Yeah. For the coefficient, we know like the coefficient equal what? Xt dot product with EG k omega naught. Am I right? The EG k omega naught actually is just the different components to generate the signals. Am I right? Yeah, and then it equals this one. And yeah, and you can see there is an integral, and this integral actually it's just the t. Do you know what's the meaning for this t? Yes, this is just like a integral, just for one period. Yeah. It's not like the it's not the from negative infinity to the positive. It's just for one period. And then you can see when compare this one and this one, just pay attention, there is a negative symbol. Okay, and then the signal analysis by FS coefficient AK. Yeah, we can represent AK like this, and also replace omega naught with the 2 pi over t. Yeah. This is also we talk about the AK related to what? Do you remember? Yeah, magnitude. Yeah, magnitude and phase shift. Am I right? Yeah. So which means with the AK actually this value related to this is magnitude. This is just the phase shift. Yeah. Okay. This is what we talked about in the previous 2 classes. And let's try to review some examples. Actually, we talk about this example, but we haven't finished this one. Give a CT periodic signals, xt equal blah, blah, blah. Determine the fundamental frequency and the FS coefficients. You remember how to determine the fundamental frequency? Yeah, pi over 3. Yeah, you're right. Yeah, but because this is just a pi over 3 multiple 2. This is pi over 3 multiple 5. So you can find the fundamental frequency. Yeah, least count multiple. Yeah, that's right. Yeah, usually if they don't have some like rules, and you just use like for the first term, the omega 1 and is equal to pi over 3, and you can get the period. And from the second item, the omega 2 equal to 5 pi over 3, and the period is 2 pi like 6 divided 5, and then you just find the least common multiple and using this equation. Yeah. T1 multiple T1 must equal T1, T2 multiple T2. And you have this equation and then calculate the T1, T2. Yeah, and then find the period T equals 6, am I right? Yeah, which means omega naught 2 pi over T is pi over 3. Yeah. If you don't know, if you cannot easily find the rule, and you just use this equation, this method, and then, by the inspection, you can easily to tell this is pi over 3. And then let's talk about for this one, the other question, find the fs coefficient. How to find the fs coefficient? Yeah, we have two different equations, am I right? Signal synthesis and signal analysis, am I right? Usually, if you want to find the coefficient, you use the signal analysis, am I right? But sometimes you just use the signal synthesis. You can easily get that one because you can see for this one, actually you can use Euler equation to transfer this one to the complex exponential form. That makes sense to you? Yeah, you can easily transfer this to this form. Am I right? Yeah. So then you can see this is just like a 2 pi t over 3. This is a 2 pi t over this one is a 2 pi t over 5. Yeah. We know like for the signal synthesis, we have this equation, am I right? So which means when k equal 0, am I right? Which means a0. Can you find a0? Yeah, let's expand this equation. Yeah, this is a signal synthesis, am I right? From this equation, can you find a0? Huh? This one. Oh, yeah. There is a form. Yeah. But can you find the a0? Huh? Yeah, what's that? Like when k equals 0, this part will be 1, right? So this is just ak. So ak equal what? Are you sure? Yeah, because you can see ft equals this one. Alright? So ak equal what? A0 equal what? AK, which means there is no like E part. Yeah, yeah, it's 2, am I right? And you can see when k equal like 1, what's a1? What's a1? What? Because if k equal 1, this is g omega naught t. It's g pi over 3t, am I right? So what's a1? There is there a g pi over 3t? No, which means what does that mean? The a1 equal what? If it is equal to, which means that you have one atom is a 2 multiple Eg pi over 3t. Am I right? But there is no Eg pi over 3t. What does that mean? Which means this atom doesn't exist, am I right? That makes sense to you? Not present? Because AK, if in one condition, this atom will disappear. Huh? When AK equal what? This atom will disappear. Huh? Let me write it down. I think that will be obvious. You can see xt equal K equal negative, and positive. AK E G T omega naught T. Alright? Since omega naught equal pi over 3, alright? We know that. Yeah, we have already calculated it, right? So which means it is a negative infinity to multiple EG EG negative infinity to pi over 3 T. And then plus blah 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 plus a negative 5 E like a negative G pi over 3 T 5. Here is a 5. Because K is negative 5. And then multiple A negative 4, blah, 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 A negative 3, A negative 0. Since 0, there is no E, and blah, 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 A1, E, J, pi over 3 T. Plus blah 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 blah. That makes sense to you? Yeah. So this equation can write down as this one until like a positive finish. Am I right? Yeah. But we have ST already. The ST equals this one. Am I right? So which means the A negative is negative infinity is what? Because because this atom doesn't exist, am I right? We have already know. I have already give you ST. What does it mean? What does it mean? Yeah, which means A negative infinity equals 0. Am I right? Yeah, and a similar thing. A negative infinity plus 1 equals 0. Am I right? Then A negative 5. Do we have E negative 5? Are you sure?
Oh, yeah.
Yeah, we have. And you can see the E negative 5, the coefficient is this one, right? And which means 2 over G, negative 2 over G is the coefficient, which means A negative 5 will have value, right? A negative 4, how about A negative 4? Do we have A negative 4? No, which means A negative 4 equals 0, right? And A negative 3, do we have? Yeah, we don't have, right? Yeah, this is, which means this is 0. A negative 2, do we have? Yeah, we have. So, which means if you find the K, or if there is a K, yeah, which means the AK is this. If there isn't, which means the AK is 0. Yeah, that makes sense to you? Yeah, so we know omega naught equal pi over, so A naught equal to, A0 equal to, am I right? Yeah, and A 2 equal A negative 2 equal 1 over 2. Yeah, because, yeah, that makes sense to you? And we don't have A4, A3, A3, A4, am I right? And A5 equal like negative 2, this is A5, am I right? Equal 2 over G, equal to negative 2G. Yeah, you know this one, am I right? Complex number. Yeah, multiple G together, G at the same time, and then G multiple G is negative 1, am I right? Yeah, so, okay, and then the A negative 5 is equal to negative 2 over G is equal to 2G. That makes sense to you? Yeah. Okay, which means for some questions, I want you to find the FS coefficient even you don't know how, even you don't know how to calculate the signal analysis. Yeah, you know, you don't need to use signal analysis. You can also find the FS coefficient based on the signal synthesis. Does it make sense to you? Yeah. Okay. Any questions so far? No. Okay. Let's try the other example. A CT periodic signal ST is a real valued and has fundamental period T equal 4. And its FS presentation is defined below. Yeah, this one we know that, right? Yeah, this is the signal synthesis and equals this one because the AK can be read into two different things. This is magnitude. This is like a phase shift. You can see this. I cannot write things here, but actually you can see E, G, K, omega T now, omega now T. Actually, this part for the it's a frequency change. You know, like as the T change, this is a frequency change, am I right? Like it's a similar like an angle change. Yeah. And then if you add like alpha K, which means like this is just the angle change. Yeah, this is just some angle, some angle. Yeah, this is also angle. This is the phase shift. Am I right? Okay, that makes sense to you? Okay, and then we know the what's the fundamental frequency? Yeah, that's right. Pi over 2. Yeah, and then the question is find the time dominant shift Tk of three harmonics given their phase shift. This one A1, A2, A3. Yeah, this one is actually it's a little tricky. Yeah, we know this is like a phase shift. Right? If you add angle here, this is the phase shift. That makes sense to you? And for the time shift, what does it mean? Time shift, which means for your signal, your time shift, you shift your time, not shift the angle. This is total. This whole part is angle, and then shift this angle. Am I right? But for the like time shift, which means you just shift this part. That makes sense to you? And that makes sense because you just shift the time. Here you shift the angle, the phase. Here you just shift the time. That makes sense to you? Yeah. Yeah. Actually, you can see this is the angle shift, this is phase shift, this is the time shift, which means we just try to find if your phase shift A1, A2, A3, what's your like time shift? Yeah, that means this is the question. Am I clear? Am I clear? Yeah. Yeah. So what does that mean? Which means here you know the K, right? So which means the K omega now T plus AK equal K omega T plus T. Yeah, if you want these two numbers has the same value, you need to let this part equal this part. That makes sense to you? Yeah. So which means like a similar thing. K omega T plus AK equal K omega now T plus K omega now TK. And this part can be removed, right? That makes sense to you? Yeah, this solve for TK. Yeah. You solve the TK here. Solve the TK. So TK equal like AK divided K omega now. Am I right? Yeah, and yeah, you can. This is, and then we know the omega now equals 2 pi over t, am I right? It's pi over 2. So which means it like pi over 2 is k pi, am I right? You can get this equation, am I right? Then you have AK, you can get TK. TK is T1, when k equal 1, then put AK A1 K 1 here, and T2 you just put that makes sense to you? Yeah. So then TK1. Huh? A1 B1 half. Oh, you mean T1, right? T1 1/2. Yeah, I think so. Yeah, 1/2. Yeah. Yeah, you can see, just use this equation. Yeah, T1 is 1/2, second, T2, yeah, if you put it also 1/2, because K will change. Yeah, and the T3 is 1/4. Yeah, you can see. We discussed questions before, like if you have a phase shift, the phase shift is absolute or the relative. Do you remember that? Actually, you can see here we also have the same conclusion. Even you phase shift even you like for the time domain you shift the same value, but for the phase shift is different. That makes sense to you? Yeah. This means that the same phase shift leads to different time shifts for different harmonics. Yeah, the similar thing. The same time shift leads to different phase shift for different harmonics. Yeah. These relatives. Yeah. Okay. Any question? Okay. And then let's talk about this one. For this one, find the FS coefficient for these signals. And when you see these signals, what's the first thing you think about? Actually, we usually don't like the square. Am I right? Yeah, we usually don't want like the square thing. Yeah, square thing means complicated. So we just want to change it to remove this square. So how? You know? Square. Actually, there is an equation. I think you know that. Yeah. Like if saying, yeah. Based on this equation, you can easily get the equation for this one, right? Understand? Based on this one, if you want to find the Fs coefficient, what you will do for the next step? Actually, yeah, usually we want to find the Fs coefficient. We will use signal analysis, am I right? But we don't like the signal analysis because you will do the integral, am I right? And we like actually we usually like if our equations can be our signals can be represented like this form, and we can easily find the EK, am I right? So for this equation, actually it's a similar thing. We want to transfer it to the complex exponential form, and then to see if we can find the Fs coefficient directly like that. So how can we convert this to the complex exponential form? How? Actually, there is an equation we can use. If you want to convert a pseudo signal to the exponential, complex exponential signals, what equation you will use? Just remember those two. The Euler equation. Yeah, this is Euler equation. The Euler equation is just you can opposite it. You remember? Yeah, just try to remember this one. This is very important for the FS part and the Fourier transform. And then you can easily get this equation to convert this equation to this one. That makes sense to you? So let's try to find the FS coefficient. What's the FS coefficient? If A0 existed, A0? Yeah, 1/2. And then yeah, okay. Is this the right answer? You think, am I right? Yeah, but I will tell you, this is not the answer. Do you know why? Actually, I talked about in the previous class, when you want to try to resolve this problem, this kind of problem, what's the first thing you want to do? What's the first thing? We want to find the Fs coefficient. We want to find the signal synthesis. What's the first thing to do? Find the fundamental frequency. Am I right? So for this one, what's the fundamental frequency? Yeah, the fundamental frequency should be Yeah, actually, yeah, the fundamental frequency is 2 omega 1. Yeah, so which means your equation will become this one. That makes sense to you? Yeah, so your coefficient, so is it, no, A0 is same thing, it will not affect, but this one is not A2, A negative 2, it's A1, A negative 1. That makes sense to you? Yeah, so you need to pay attention. If you want to resolve those kind of questions, you need to determine the fundamental frequency firstly, or fundamental period. Okay. Any questions so far for this question? Okay. Then yeah, A key equal if key otherwise it will be 0. Yeah, that makes sense to you. Okay, then let's try to talk about, yeah, you can see our goal is to study three cases of typical Fourier series computation problem, and let's talk about the first one, the case one. Yeah, actually for the Fourier series problems, usually we have those three different cases. And the case one is given fx coefficients ak, let you find a signal xt. How will you resolve this kind of case, this kind of problem? I give you the fx coefficient ak and let you to find the signal st. Which equation you will use? Huh? Euler equation? This is for, yeah, it's for this equation, you for this one, you need to use signal synthesis. Yeah. Yeah, but the first step, you must find the fundamental frequency, omega naught, am I right? And then convert non-real fs coefficient into polar representation. Actually, we talk about, yeah, this one. Because you can, yeah, and use the fs synthesis equation to represent the signals. Yeah, this one equal this one. Yeah, that makes sense to you. Okay. Yeah, equal this one. It's the same thing. Use the Euler equation to merge conjugate pairs. Yeah, two can be transferred to sinusoidal signals. Yeah. Okay. And then, yeah, for this is like a Euler equation. Yeah. Just remember those two. Yeah, when we have the midterm, just put those two equations in your cheat sheet. Yeah, okay. And then let's talk about, yeah, you can see we actually this example we have already discussed about. Do you remember? Yeah, there is, I give you some like fs coefficient and you use the synthesis equations and to have the signals, right? Yeah, I will not. Do I need to talk about details? I think you have already, yeah, you know that one. Yeah, you can see this is just like the case one, am I right? And also this one, yeah, I give you some like coefficient and let you to find the represent st in terms of the blah blah blah. Yeah, and you can see firstly we find the fundamental frequency, and then the A3 is just like you need to convert it to the polar representation, and then use the synthesis equation to represent the signals. Yeah, that makes sense to you. Yeah, this example also is the case one. Okay, let's talk about case two. Case two is given a signal composed of sinusoidal functions, find the fs coefficient. Okay, for this one, what's the first step? Yeah, that's fine. Find the fundamental frequency. What's the step two? You can see this, we have sinusoidal function, am I right? Yeah. Use Euler equations to represent the sinusoidal functions with like complex exponential signals, and then yeah, use this one. Okay, and the step 3 is just a match with the synthesis equation to find the fs coefficient. That makes sense to you? Yeah, this is case 2. Actually, you can see for this equation, for this example, yeah, we just talk about this example. It's just a case 2. Am I right? Yeah. Do I need to review it? Right? Do I do that? We don't need it, am I right? I have already talked about that. Okay, and for the case 3, which means give an arbitrary signals, find the fs coefficient. Yeah, for this one, what's the first step? Yeah, find the fundamental frequency. Yeah, and then step 2. Yeah, since it is arbitrary like signals, we cannot convert the signals to complex exponential signal usually. So then we just follow the equations. Yeah, analysis like signals analysis signal equations. Am I right? Yeah, according to the FS analysis equation to compute the integration or integral. Yeah, and the computer actually usually compute the in-out average first. Yeah, and we will talk about y. And then, yeah, this is in-out. In-out equal t. Do you know why there is no e? E, G, K, because k equals 0, which means the e part is 1, am I right? Yeah, so this is in-out. And then compute AK in general. Yeah, this one. That makes sense to you? Any questions so far? Okay, let's talk about some examples. And actually, when you compute AK, we know like this is just in one period, right? So you should choose the integration period carefully. Yeah, because if you choose a not good period, and maybe you will make your computation like more complicated. Yeah, we will talk about that. Yeah, for example, this one. This is a signal, and this signal is that's a you can put it like this. Yeah, this is a representation for this signal. Okay, so let's talk about let's try to represent these signals in FS representation form. Okay, so let's find if we want to represent the signals in a like a FS representation form, like we need to use FS which equation? Signal synthesis, am I right? But if we want to use signal synthesis, we need to know AK, am I right? So the first step, we need to find the AK. That makes sense to you? Yeah, so we know AK equals this one, am I right? And then firstly, we know like we should calculate the A now firstly, am I right? And then no matter you calculate the AK or A now, how to choose a period? What's the period for this signal? What's the period? T, am I right? Yeah, the period is T. And so how can you choose the period? If we want to do the integral, the integration, and what's the upper boundary and the lower boundary and the upper boundary? 0 to t, am I right? Yeah, that's a option. But you can see if you choose 0 to t, which means you need to integral those two values, am I right? But if you choose the value from 2t over 2 to the negative t over 2 to t over 2, what does it mean? You just need to focus on this one value. That makes sense to you? So that's the reason why you need to choose the period carefully. Yeah, you can see if you choose 0 to t, yeah, it works. But if you need to like your signal will like multiple will plus the other action, and you will make your computation like complicated. That makes sense to you? Yeah. Okay. And then actually this signal the AK should equal 1 over t. Yeah. You know why? Yeah, actually, you can see from this equation. This is your AK, am I right? Okay, and your AK should equal 1 over t. Yeah, you can see. We know like this equation equal xt and actually this part, for this part, yeah, you can find you can like rewrite your part to this equation in this equation, and you will know like you for this part you can write your equation like this, and then it will equal 1/t because what is your xt when t equals 0 or t naught? You can see the integral xt is always the 1. Am I right? So which means this part is it's just a 1. And listen to this part. Yeah, it's just this part left. Am I right? 1/t. Okay. And then let's talk about yeah, this is the for this example. And then let's try to find the other example, this one. The periodic square wave sketched in figure 3.6 and defined over one period as this one. And is a signal that we will encounter a number of taps through this. The signal is parallel and the fundamental frequency. Yeah, you can see we have a signal xt, this one, right? And then like our question is what? Oh, we want to find the like coefficient, like fs coefficient, and you can see this signal is now sinusoidal signals. I'm right. It's not like other spectral signals. It's just arbitrary signals. So we need to use the case 3. So we need to use this equation. I'm right. And for this equation, you can see what is period? Period is t. I'm right. You know, we know like period t. And when you choose the period, which period you will choose?
Like the T over T.
Yeah, because it only includes this one, right? If you choose from here to here, they will include this part and this part. Yeah, okay. And then, yeah, from the, yeah, T negative T1, yeah. Since from this, from here to here, only this, during this part, you have value, right? Other part doesn't have value, so your equation should similar like this one, right? Yeah, and your xt equal what? 1, right? For now, here we just calculate the A naught, and then you can see what's your A naught. Your A naught equal to E1 over T. Am I right? Yeah. So, and then, yeah, it is just a average. Yeah. Usually the average is like is separately computed. Yeah. That makes sense to you? Yeah. Okay. And then let's continue to talk about this one. Actually, we know like the this AK equal this part. Yeah, because for now we just calculate the A naught. Am I right? Yeah, and we need to like find the like AK. Am I right? And for the A naught, do you have any questions?
No.
No? Okay. And for the AK, yeah, we have this equation. And then for these equations, yeah, we just use this one. Yeah. This is just the regular like integration value, and the like t duration from t negative t1 to t1. I'm right, and then you put the t1 and minus negative t1. That makes sense to you, and you can get this one. Yeah, and this, yeah, and then if you want, usually yeah. This is AK, and usually we want to change AK to the sinusoidal form. Yeah, so we use the Euler equation, and then you can see this one. We can try to put this to this one. That makes sense to you? Yeah, and then okay, and we have this equation. The AK should equal to this one. Okay, let me ask you questions. Yeah, omega now t equal 2 pi. Yeah, since omega now t equal 2 pi, so we have this equation. Am I right? And then let us talk about one question. Do you see why we know is separately computed? You know?
What they then
Huh?
gave us last time,
The game, the what?
what they gave us for like,
You can see this is key, right?
yeah,
The inner, which means key equal 0, right? Yeah, for this equation, if the key equals 0, what will happen? If key equals 0, it cannot, it doesn't work because this part, the fraction, for the fraction, this part cannot be 0. That makes sense to you? Yeah, do you, yeah, for the mathematical thing, am I right? Yeah, so which means the inner, you cannot get inner from this equation. Yeah, that's the reason why the inner should be like computed separately. That makes sense to you? Okay, and then actually those two those two functions, those two signals, like this one, the a key equal 1 over t, and this one, the a key equal this one, but the a now is a separate. Those two, like is are two often use the fs pairs. Yeah, and what kind of fs coefficients? Okay, let's review. For the first one, for the first signal, what is the like AK? We know like the xt equal this one, right? Yeah, we know xt equal is this one. What's the AK for this equation? For this signal, we have already talked about that. Yeah, I think the AK equal 1 over t, and then yeah, for this equation, for this signal, the AK A0 equals this one, and the AK equal this one. Yeah. Actually, this is just a two very often used fs pairs. We will use those two for many different questions in the following classes in this chapter or maybe the next chapter. Yeah. Okay. And then let's try to have a deep look of fs coefficient. Just this one, just this part. Okay, for this AK, we have this AK, am I right? Do you know like there is a function called a sinc function? Do you know? No? No? Actually, this sinc function, the definition for sinc function, you know that, right? Sinc function is just a, yeah, the sinc function is just the definition for the sinc function is sin pi x divides pi x. Yeah, this is the definition for the sinc, like a sinc function. And for the sinc 0, it is 1. Yeah, we just define the sinc 0 is 1. Do you know why we just don't use this equation for sinc 0?
both are Steve.
That's why we want to separate those two. Like why we just use this equation to represent the sinc function. Why we just put the sinc 0 separately. Yeah, you can see if the sinc 0, which means x will be 0, am I right? Which means this part will be 0. Sorry, this part will be 0. It's forbidden. Yeah, so we need to separate it. Yeah, this sinc function is just a definition.
Okay.
Yeah. Okay. Then let's try to find the difference, the relationship between the AK with the sinc function. Okay, for the AK, we know the omega now equal 2 pi over t, am I right? So we can write this equation to this one, am I right? And then we can write this part to this one. You can say it's the same thing. We just add something here. And then from this one, we can put it this one. Is yeah, because this one and this one is the same thing. That makes sense to you? Yeah, so this part is just this part. That makes sense to you? Yeah, because this we can consider it is pi t, like a pi x, and this is pi x, and this is just sink, this one. That makes sense to you? And this is just like a try to put a t here and two t1 here. Am I right? Yeah. Actually, the sink x, you can try to the a key if you draw it. It's just like this. What does that mean? What does that mean? Yeah, which means the a key, this is 0, which means p is 0, k is 1, -1, -2, and 2, -2, 3, -3. Am I right? What does that mean? Which means the a key, a0 is the biggest value, and then the a1, a-1, am I right? And then a key, a2, a-2, am I right? What does that mean? Which means when the key equals 0, it has the biggest component. And then as the key increase or decrease, yeah, it will affect the signal like smaller and smaller. Yeah, this is just this kind of signals. Yeah.
So you use the quantity for the signal greatest.
Yeah, this sank signal is just the if you draw it, it looks like this. And but we just try to draw the a key, let you to know when the key is close to 0, and that component will affect the signals more. That makes sense to you? Yeah, which means yeah, only these signals like for the synthesis. Yeah, okay. You can see these signals, am I right? It is infinite signals, am I right? From the negative infinite to the positive infinite. But in the frequency domain, when the frequency equals 0, when the frequency equal like only one over like 1 omega naught, like omega naught, like 2 omega naught, like 3 omega naught, this frequency is just pick up the signals in a very heavy like a part, very big part. But other frequency will affect these signals very little. Yeah, which means now all the frequency affect one signals equally. Yeah. This is just like we want from this FS coefficient, we want to know these things. Yeah, sometimes only like some frequency like decide these signals. Yeah, other maybe affect, but very little. Yeah. Okay. Any questions? Okay. Yeah. We will talk about FS properties next in next class. Okay. Any questions? Just let me know. Okay.